Okay, this is Professor Keen. Today I want to talk about how it is that Pascal's principle can be used to explain why it is that fluid is level. So we're going to use Pascal's principle. Oops, let me use the color ink that I'd like. So Pascal's principle and that is that F1 over F2 equals A1 over A2. Whoops. Over A2. This is the principle that we've been talking about for the past several short lectures. So here's what I want to do. I want you to imagine that you have, as we've been doing before, we have a large chamber full of fluid. This is the way that Pascal explains this. Erase this to make it look nice. So we have a large chamber. Okay, and in the top of this chamber we have two openings. I'm going to make one opening over here that's small and one opening over here that's large. And as Pascal explains, imagine these are tubes that are soldered into this large chamber. What's going on? Try that again. We have these two chambers that are soldered in like that. And let's suppose that this entire chamber is filled with fluid. So I'm going to imagine that the fluid is filled up to some depth on both sides. These are openings, of course. So the fluid is in the chamber and it's also filling up these two openings and these two tubes that are coming out of the top. And this fluid right here has some weight, and so it is pushing down on the fluid inside of the chamber with some force F1, and this fluid here has some weight and it's pushing down on that fluid inside the chamber with a force F2. Let's suppose that this area here is area 1 and this area here is area 2. And the question is, how high is the fluid in this side? We'll call this height H1 compared to the height of the fluid on this side. And the height over here is H2. And what I'm going to do, I'll just give away the secret here. What I'm going to do is demonstrate how it is that Pascal's principle implies that height 1 is equal to height 2. In other words, when you pour liquid into here, the fluid on the left side rises to the same level as the fluid on the right side. In other words, I'm going to prove that H1 equals H2 using Pascal's principle. Okay, so how do we do that? Well, let's start with Pascal's principle that F1 over A1 equals F2 over A2. In other words, this chamber acts like a machine for multiplying forces. So if you have this force here over this area and this force here over this area, they have this relationship. We've been spending the last couple of lectures explaining why that is. Okay, now let's suppose, for example, that area 2 is 4 times area 1. So this here is 4 times as big as that. Okay, if that's the case, then we know that F1 over A1 equals F2 over 4 times A1. That's what we just said. So that implies that F1 is equal to 1/4 of F2. Or we could say F2 is 4 times A1. Oops, I said that wrong. 4 times F1. Back here, 4 times F1. Okay. All right. Now, how is it possible that the force here is 4 times as big as the force right there? Well, what is F2? F2 is the weight of the fluid on the right. And F1 is the weight of the fluid on the left. That is, F2 is the weight of all this fluid in here, and F1 is the weight of all the fluid over there. How do I express this weight? So F2 is going to be equal to the mass of the fluid on the right, that is M2 times G. And F1 is equal to the mass of the fluid on the right, M1 times G. G, remember, is this conversion factor between mass and force. Okay? And what is the mass of the fluid on the right? Let me move this over to give myself a little more room. In fact, let's get rid of those entirely. So what is F2? Well, mass 2 is going to be the density of the water or whatever fluid we have times the volume of the fluid on the right. And M1 is the density times the volume of the fluid on the left, right? And if I keep going here, the density, what is the volume of all this fluid right here? Well, it's going to be this equal to the area on the right times the height on the right, right? And the weight of the fluid on the left side is density times area 1 times H1 times G. Okay? Now, keep in mind, we're trying to show that if the area 2 is 4 times area 1, then force 2 has to be 4 times F1. So how is this possible? F2, I'll rewrite this over here, is 4 times F1. Well, we just said F2 is the density times area 2 times H2 times G. And on the right, this is 4. F1 is the density area 1 H1 times G. Notice the G's cancel out, the densities cancel out, and we're left with A2 H2 equals 4 A1 H1, right? Well, now remember that we assumed from the beginning that area 2 is 4 times area 1, so we'll have 4 times area 1 times H2. This 4 area 1 is what I'm plugging in for A2, is 4 times area 1 times H1. Notice I have a factor of 4A1 on both sides, so I cancel those out, and I'm left with H2 equals H1. Voila, that is exactly what I wanted to prove. I wanted to prove that Pascal's principle implies that if I fill this chamber with fluid, the heights on the left and the right-hand side are going to be the same. Why are the heights on the left and the right the same? Well, because this fluid-filled box acts like a machine that multiplies forces. In other words, you need to have 4 times as much weight over here as over here for them to be in equilibrium. How is it possible for there to be 4 times as much weight over here as over here? Well, because it's 4 times as much area, they have to have exactly the same heights, and that's what I've determined right here. So Pascal's principle, this is a summary then, Pascal's principle explains why fluid is level. And that is all that I want to say for today.